In this video, we'll be looking at the base graph y equals sine x. When we plot the base graph of y equals sine x, it's a result of using 5 key points. We're using degree measures, so what I've chosen to use are 0, 90, 180, 270, and 360. The reason we choose these values is because they give us nice y values that are easy to plot to produce the graph. So, if we look at these points, 0, 0, 90 and 1, 180 and 0, 270 and negative 1, 360 and 0. We see that we've got a periodic function, or a cyclical pattern, something that repeats itself. Because after I go through 360 degrees, I arrive back where I started. So it's as if I've taken this part of the graph and then just pasted it again next to the first part. Because the next value I'll get will be back up to 1. So we would say that the period of this graph, the time it takes for it to repeat, is 360 degrees. And it won't matter what 2 points we choose to show this. For instance, I chose those first 5 points. We went from 0 to 360. If we were to choose the crest of this and the crest of this part of the graph, we would see that we would be separated from 90 to 450. So it's still a separation of 360 degrees. If I choose this point here at the end, then I would be comparing it to the 180 back here, because those are in the same position. And again, they would be separated by 360 degrees. The other important value we'd like to look at on this graph is the midline. The midline is the point that's halfway between the maximum value, which in this case is 1, and the minimum value, which in this case is negative 1. So it's this line right through the middle. It kind of cuts the wave in half. So we see all those points have a y-coordinate of 0. So we have a line lying here. We call this the midline. And we use the midline to measure an important piece of information for our sine function. And that is called the amplitude. So when I look at my graph, if I look at the distance from any point along the midline to the maximum or minimum point, the distance should be the same from the midline to the maximum and from the midline to the minimum. So if I look at the coordinate 0 here, if I go to my minimum value, I have negative 1. So there's a distance of 2 blocks, or 1, for the amplitude here. If I look in the first part of my graph here, if I go from the graph down here, which is at 0, up to 1, I have a distance of 2 blocks, or an amplitude of 1. And no matter where I choose there, if I come to 450, I still have a distance of 1. So the amplitude remains constant, and it's an important feature of the graph, especially when combined with the midline and period, which in this case for the base graph is 360.